Good afternoon. Today we will formally enter into the multivariate domain. Now, topic is multivariate descriptive statistics, and the content of today's presentation includes multivariate observations, mean vector and covariance matrix, correlation matrix, sum square and cross product matrices. So, it will be purely data. We will be dealing with data with symbols like x. So, in univariate statistics, univariate descriptive statistics, you have seen central tendency measures as well as dispersion measures. Correct. Univariate case you have seen earlier in class these lecture classes. Now, central tendency you have measured in univariate case using mean, then your mode and median. These are the measures we have adopted, and under dispersion you have used range, then I think IQR, interquartile range as well as standard deviation. Okay. Now, we will see some of the counterparts in the multivariate domain. For example, mean will be mean vector. When you go for this multivariate statistics side, you will find out that mean will be mean vector, and the standard deviation, another component which is the measure of dispersion, that will be not standard deviation, its square, that is the variance. Variance will be covariance matrix. Covariance matrix. In addition, as there will be more than one variable, so there will be correlation between variables. So, we will be knowing correlation matrix also. Today's discussion will be concentrated on mean vector, covariance matrix and correlation matrix. Okay. Now, think in little bit on in abstraction level now, that there are a multivariate population, there is a multivariate population, and that population is characterized by a variable vector which is known as x. There are p number of variables which is characterizing the population of interest. So, it is a p cross 1 vector. What does it mean? We are saying we have created a vector x which is p cross 1 vector, where p stands for number of variables. So, there are variable 1 which is x 1, variable 2 is x 2, like variable p is x p. Okay. Now, you think that you require to collect data on these p variables. So, I am writing here, so my first variable is x 1, second variable is x 2, like my last variable is x p, and you are basically collecting data on these p variables. So, you will be collecting observation 1, observation 2, like this n observations. So, essentially you are not in univariate domain, you are in multivariate domain, and you are not only in one x with several that n values, that means 1 to n values. Here you are with I equal to 1 to n and j equal to 1 to p. So, what does it mean? I equal to 1 to n, these are the number of observations, and j equal to 1 to p, these are the number of variables. Okay. Now, you think of a situation that you have your population, you know that variables, p variables are there, you identified the variables. Now, you are planning to collect data, you have not collected data, you are planning to collect data. Then our nomenclature, the way we will be writing here, we will be writing like this: the general observation will be x I j. What does it mean? X I j means that is the ith observation on the jth variable. Ith observation on the jth variable. That is why I stands for 1 to n, which is number of observations, j is 1 to p, number of variables, x I j, which is the ith observation on the jth variables to be collected. If this is the case, that means we are first writing the variable, then we are writing that what is the observation number, then we are writing what is the variable number. So, then this is observation 1, variable 1, so x 11, observation 2, variable 1, x 21. So, like this you are writing observation n, variable 1. My second my observation on the second variables will be x observation 1, variable 2, x observation 2, variable 2. So, like this x observation n, variable 2. So, in this manner you will go, then x observation number 1 on variable p, observation number 2 on variable p, like this you will be getting observation number n on variable p. This is the data matrix and we will be denoting this as capital bold X, capital X, bold X, and the order will be n cross p. Capital bold order will be n cross p. It is visible.
Yes.
Okay. This one I am saying this is a data matrix which you are planning to collect. If this is the case and you all know that x is a random vector, here x 1 to x p, x is a random vector because all the variables are random variable here. So, x I j is the ith observation on jth variable, this is also a random variable. Okay. This one please keep in mind, this is also a random variable, we are writing it as random observation. So, as you have not collected data, you have just planning to collect data, any value of x I j can be found depending on the spread of that variable, you will be getting any value of this, but you do not know what is that value. So, that is why we are saying it is a random, it will be random observation and it that x I j is a random variable, will be random variable. Okay. So, you can expect value of x I j, getting me? You will get some, you have some expectation. So, that so you will see in univariate case that if x is random variable, then expected value of x is mu. So, if this is the case, then for every variable here it has also some expected value. So, that is what we will basically talk about the mean vector. Okay. So, before coming to mean vector, another two important issue is there that to be discussed here. Suppose the observation is ith observation and there is the variable is x j. This also the what will be the, I told you that the general, what I have given you here, that this is the general observation x I j. So, similarly there will be a general observation, multivariate observation, general observation, similarly there will be a general variable. Now, if it is I, suppose this one is I, this is the ith multivariate observation. So, your value will be x observation number I variable 1, observation I variable 2, like this. If I go observation I on variable j, then observation I on variable p. Okay. So, if I write that x I is the ith multivariate observation, ith multivariate observation, can I not write like this, that x I 1, x I 2, x I j, x I p. This is a p cross 1 vector, correct. Now, if I go by the variable y, so that means when I talk about the ith multivariate observation, please keep in mind that is the observation, a particular observation on all the variables. The why it is not that what is the in univariate case, what will happen, you will get the one value only for that observation. As it is multivariate, you are getting all all values on p variable, but the other thing, important thing is that it means all the variables are occurring simultaneously, simultaneous occurrence, that is why multivariate in nature. Now, if I go by the general, our general variable which is x j, then this observation will be x observation 1 on variable j, observation 2 on variable j, and observation I on variable j, similarly observation n on variable j. So, you will be getting a general that means observations on a particular variable, that way we will write. So, if we write like this, that x j, this is what we is that is the observations on n observation on jth variable, then this is x 1 j, x 2 j, like this, x I j, then x n j, it is a n cross 1 matrix. So, that means essentially what is happening, you have one hand this side that the observations, number of observations axis, and other hand you have number of variable axis. So, when you go row wise, you are basically talking about different multivariate observations, and when you go column wise, that means you are talking about n number of observations on different variables, that observation on n observation on variable 1 to variable p. Okay. So, but what we have assumed here, we have assumed that we have not collected the data, we are planning to collect data, and as a result all the entries in this particular matrix are random in nature. What will happen if you collect the data? When you collect data, the same thing, you will collect data on same number of variables x1, x2 like xp, and your data matrix also will be n cross p. Here also you will be getting I equal to 1 to n like x11, x21, xn1, x12, 22, xn2, then x1p, 2p, xnp. This you will get. Here also your xi1, then xi2, somewhere xij, then xip, that general observations will be there, which we can write like this, which we will be able to write like this, that xi, which is xi1, xi2, xij, then xip, that is p cross 1, and also you will be getting one general variables, that observations. So, we write that xj, if we write, you will be getting x1j, x2j, like this, xij, then xnj, all remain same. It is after data collection. Then my question is, what is the difference between the first matrix and second matrix? This is our second matrix, where we said that after data collection, and this is our first matrix, we say this is before data collection. What is the difference? The
second matrix, there is no any random.
The second matrix values are known. So, it is either fixed values now. From the data collection point of view, they are fixed values. First matrix, you don't know what value you will get. So, that is why in the first matrix is when you don't know anything, that you will expect some value for each of the variable, that will be mean. You also expect some deviation of different values from the mean, that will be your variance, and you also expect that two variables will be covary, that will be your covariance. So, that is from the population point of view. Now, let us see this data set. Okay. Now, if I ask you what is the X matrix, data matrix. So, what is the n value? N is 12. Now, months we are excluding for the time being, although month can be included as variable. For the time being, let month is excluded. Then 1, 2, 3, 4, 5. So, your data matrix is 12 cross 5. All the variables are measured for 12 observations. So, if you see this, then see this is the data matrix, this one 12 cross 5, oh this not coming here, 12 cross 5. So, the left hand side matrix, the data matrix is X 12 cross 5, 12 stands for N, this stands for P. Okay. Anyhow, now we will just find out. Our aim is, first we will see the expectation of the variable values. For each variable, what is the expected value? Then we will see that when you collect data, what is that value. Okay. Now, you see this slide, where that as there are p variables, so there are p means. These are population parameters. This mu is the vector which represent p means for the p variables, and it is mean vector and which is a parameter vector for the population. And I have written here that it is expected value of x 1, expected value of x 2, expected value of x j, expected value of x p. And you have already seen that what is the expected value of x, what we have written earlier. If your variable is discrete, you give a summation and then you say all x, x f x. Here what happened, we have basically so many variables at hand, we are writing like this: expected value of x, j stand for the variable, for a particular variable jth variable, then we can write all x j, x j f x j when it is a discrete variable. When it is continuous, what will happen? What you write in continuous case here? You have seen continuous case, you write integration minus to plus infinite x f x dx. So, I am writing here for continuous case integration minus infinite to plus infinite x j f x j d x j. So, for both the cases j equal to 1 to p. This is your expected value. So, this when you write down for mu, what is mu? Mu is a vector p cross 1 vector which is mu 1, mu 2 like mu j, then your mu p which is p cross 1 vector. This is nothing but as we discussed now, expected value of x 1, expected value of x 2, then expected value of x j, then expected value of x p, and expectation we will calculate like this. Correct? So, when you collect data, we have two sets of matrices. One matrix we say that we have not collected data, that is before data collection. With respect to this, we are developing this one, this. So, we are saying that our topic now is mean vector. When you collect data like the one I have already given you, that 12 into 5, then our data matrix is this after data collection, and we want to compute the average value only, because we have seen in univariate case what we have seen? We have also seen that x bar is the estimate of mu. So, in our case we are writing x bar which is nothing but x 1 bar, x 2 bar, x j bar, x p bar, that is p variable average vector. Now, what is your x bar in case of univariate? You have written 1 by n sum total I equal to 1 to n x I. So, that means I can write this one now in the same manner, that this one is I equal to 1 to n 1 by n I equal sum total I equal to 1 to n x I 1 I can write. 1 stands for the variable, I stands for the observation. Similarly, second one you can write sum total of I equal to 1 to n x I 2. So, in that same manner for the jth case you can write I equal to 1 to n x I j, and the last one you can write I equal to 1 to n x I p. This is my mean average vector for the sample collected on p variables. Okay. So, we will not go for individual mean calculation or average calculation. Instead of doing this, we want to do matrix calculation, vector matrix, that matrix algebra calculation. What we will do here, see, I have, in order to calculate this x bar, we will take this data matrix first. What is our earlier data matrix was there? This data matrix was x n cross p, which we say suppose x 11, x 21, like this x n 1, x your 1 2, x 2 2, then your x n 2. So, like this x 1 p, x 2 p, your x n p, that was my sample data, and it is n cross p. You want to compute x bar from this sample data, and x bar is a p cross 1 vector, that is x 1 bar, x 2 bar, x j bar, x p bar. So, and you know the formula also, you know the general formula, suppose x j bar is 1 by n sum total I equal to 1 to n x I j, that also you know. Okay. Now, in matrix, in one go you want to calculate all those things. What you require to do, that means, when you calculate in matrix domain, please remember, I have n cross p matrix, I want a p cross 1 matrix. I am going from, suppose this is n cross p. So, you have n cross p, you are going to p cross n. That means, what if I create one matrix which is, let it is 1, big 1, symbol 1, which is all ones, 1 1, like this, there will be n ones, n cross 1. I am creating one unit vector where all there are n elements in the vector and each element is 1 only, getting me. Now, this I want to use this this unit vector with this data matrix in such a manner that I will be able to apply this computation formula and I will be getting the a p cross 1 vector. Okay. So, that means, if I create like this, suppose p cross n into n cross 1, is it p cross 1 from matrix multiplication point of view? Row column. So, here number of column is number of row, equality is there. If I want to do this, that means, I have to transpose this matrix. I have a matrix called x with n cross p. If I do transpose x t, this will be p cross n, row and column will be interchanged. So, I am doing this x transpose, this is p cross n, I will take a dot product, that is n cross 1. So, your resultant matrix will be, definitely it will be, this will be cancelled out and it will be p cross 1. Okay. So, what will happen with this, you see now. So, your data is like this. So, I am taking now, let p equal to 2, n equal to 3, just to reduce the complexity of repeating the same calculation. Then my X matrix will be 3 cross 2, which will be like this: x 1 1, x 2 1, x 3 1, then x 1 2, x 2 2, x 3 2. As there are 3 observations, so let you create one unit vector which is 1 1 and 1. This 3 is required because my n is 3. So, I want to multiply x transpose 1. So, what I will do then, x 1 1, x 2 1, x 3 1, that is the first row, second row x 1 2, x 2 2 and x 3 2, this is my second row, because I have made the X matrix transposed. So, then you multiply this by 1 1 and 1, and we all know this one is a X transpose is 2 cross 3 and 1 is 3 cross 1. So, we will be getting a resultant matrix which is 2 cross 1. So, then matrix multiplication point of view, x 1 1 into 1 plus x 2 1 into 1. So, that is what? I equal to 1 2 3 x I 1. Second one will be I equal to 1 2 3 x I 2. Now, we have seen earlier that what is x j bar, that is 1 by n, sum total I equal to 1 to n x I j. So, if I divide these resultant things by n, I will get the mean vector. Okay. So, that means I can write x bar is 1 by n x transpose this one, or you will be able to do it very easily, because this formulation is much better, because you can multivariate domain hands on that calculation type you forget. You have to use MATLAB for understanding the computational part. You can nowadays Excel is very powerful also. So, Excel also you can use. Using Excel you can use this formulation very easily. I think I will be giving you tutorial and you will have to do this, and then if you find problem, talk to me again in my chamber also, absolutely no problem. Okay. So, will you be able to compute the mean vector log given data? Now, see this slide. Suppose you take these first 3 values for the first variable and also first 3 values for the second variable, and use this that matrix multiplication. Can you not do? What I said, that we are taking only 2 variable case with 3 observations 10, 12, 11, then 100, 110 and 105. So, I want to get the x bar, what we are saying, x 1 bar and x 2 bar. You can very easily you can go like this. Okay, 10, that is 33, the total is 33 here, the total will be 5, that will be 1 0 1 1 1 and 3 3 1 5. If you divide it by 3, it will be 11, that first one variable 11 and second one will be 1 0 5. So, that means your x bar is 11 and 105, that you can very easily do here also, but I am saying that you use this formulation, that x bar equal to 1 by n x transpose 1. If you do like this, 1 by 3 x transpose will be 10, 12, 11, 100, 110, 105 and then 1 1 1, this is nothing but 1 by 3 into 33 315, which is your same thing 11105. It seems or that means here and here there is not much of difference in calculation. The reason is because number of observations is also less, number of variable is also less, but you have to have P means a large number of variables with large number of observations. So, that individual calculation is not required, straight away go for matrix multiplication. We will be using simple matrix multiplication, matrix inverse and other things throughout the I can say the lectures. Okay. So, this is what is mean vector, and from the population point of view and from sample point of view. From sample point of view, sample average is the estimate of population mean vector. Okay. Now, come to covariance matrix. See, you have to understand it. Now, although things are very simple, but physical meaning of each of the items must be understood. Then only later on we will be talking about covariance matrix. I will not give you, will not come back to the physical meaning of covariance matrix further. We will simply say covariance matrix. That means, you will be able to catch what is covariance matrix immediately, then only you will be able to relate the discussion that time. Okay. So, we are interested to know covariance matrix. So, let us discuss from population point of view first, that is population covariance matrix. Correct. If I say my x is a random variable univariate case, then if I ask you what is the variance of x, then you will say that it is expected value of x minus mu square, yes or no. And you have also seen for your discrete case that all x minus mu, or if I find x I minus mu this square, then f x I we are not using now, let it be general case like this. So, that is why I have written all x. And when you go for integration, you write like this plus this x minus mu square f x dx. This is what? This is the variance component, which is sigma square. ठीक. So, now I will do simple alteration. Instead of ax, I will write xj. That means, I want to know the variance of xj. Then you will write, it is nothing but you will write xj minus mu j, only j will be the added there everywhere. Then what you will write? You will write sum total of all xj minus mu j square f xj. This is for discrete case, and you write like this integration minus infinite to plus infinite xj minus mu j square f xj dxj. This is your continuous case. All right. Fine. Now, if this is the case, and if I what is required, that means for j equal to, if you put j equal to 1 to like p in this formulation, whether it is discrete and continuous, when you put j equal to 1, what you get? You will get sigma 1 square. When you put j equal to 2, you get sigma 2 square. So, like this you will get sigma p square. That means, the variance component of all the variables coming from this equation. But we have seen that we have p number of variables, and what we are also assuming that these p number of variables are not independent each other. If x 1 is dependent on x 2, or x 1 and x 2 are not independent, what will happen? For example, height versus weight of people, non-zero. So, that means they have correlation, or other way I can say there is a very much, suppose if someone height is more than other one, it is naturally that weight also more naturally, but there are other parameters also which govern that weight, but naturally this is the case. So, when they are not dependent, not independent, they are dependent, then what will happen? That means, when x vary, x 1 vary, x 2 also vary. So, their simultaneous variability is known as, what do you want to say, x 1 and x 2 co-vary, they simultaneously vary. If they co-vary, there is covariance, means association between their realization of the values of x 1 and x 2, fine. So, now I will write again variance of x j, we have written expected value of x j minus mu j, that square. It is basically what this one, if I just do little manipulation and if I write like this, that there is a formulation called covariance between x j and x k. If I write like this, x j minus mu j into x k minus mu k, you see the similarity between these two. When I am talking about variance of j, I am saying x j minus mu j, that this one I am further writing x j minus mu j and x j minus mu j, that is why the square is coming. That means, same variable I am saying that, suppose it is repeating to creating two variables, same on that it x 1 on x 1, that sense if you do like this. So, the covariance is this, as I am saying, if x j vary, x k also vary, there is a chance, that is why I am expecting that what is the association between the two, getting me. So, in that case we can again write down, suppose the same formula, that all x j x k, x j minus mu j, x k minus mu k, what we will write here for probability density function? Can we write that if x k and x j separately, or we will write x j joint probability, getting me? We have to write the joint probability here, and continuous case you have to write like this. It is double integration, or here I have written all x j x k simultaneously, that one summation symbol I have given, but otherwise you have to write all x j all x k, all x j all x k. What is the notation for this? We will use the notation for this is sigma j k. keep in mind we have used sigma j for standard deviation, sigma jj for variance and sigma jk for covariance. So, what I am writing here that this is sigma jk. Now, be careful about the notation now, that sigma j square equal to sigma jj. Later on we will be using sigma jj, sigma 1, that is the variance component, which is basically, if I write sigma 1, it is sigma 1 square. Then we will be using sigma jk, which is, this is your variance of xj and this one is covariance between xj and xk. Okay. So, you have sigma j square, you have sigma jk and you have p number of variables. Can we not find out the population covariance matrix now? We are now in a position to write down the population covariance matrix. As there are p variables, so covariance stands for every 2 variables. So, how many elements will be there? So, let us write down like this. We will create a matrix P cross P. P stands for number of variables. So, that means this is x 1, x 2 like x p, again x 1, x 2 like x p. So, x 1 and x 1, the variability, then when x 1 is varying with x 1, the same variability is variance. So, this one will be sigma 1. For the second case x 2, this will be sigma 2. So, like this, for p variable case x p is sigma p p. This diagonal lines, all the elements in the diagonal lines are variance component, that I am saying this is basically variance component, variance part of the variable that, as I told you, sigma 1 only equal to sigma 1 square, sigma 2 equal to sigma 2 square, like this variance. Then the off diagonal elements will be covariance. So, what will be this? Sigma 1 2, sigma 1 p. Sigma, again I am writing 1 2 instead of 2 1, that what is the assumption we are doing? Sigma j k equal to sigma k j, because jth variable, kth variable, same 2 variables only, but in order we are changing. Then sigma 2 p, like this you will get sigma 1 p, sigma 2 p, this. So, off diagonal elements, these are covariance part, diagonal elements are variance part. These resultant matrix in our class we will be denoting it like capital sigma. So, keep in mind capital sigma whenever we will be using, this is your population covariance matrix. So, population covariance matrix looks like this, the way the same thing here, you see sigma 1 sigma 1 2, sigma 1 j, sigma 1 p, sigma 1 2, sigma 2 2, sigma 2 j 2 p, like this. If there are p variables, there will be p cross p elements, that this that will be p cross p, that will be the size of the matrix. Okay. Now, we require to know sample covariance matrix. getting me? So, this matrix, this population covariance matrix, sample covariance matrix, very vital component of multivariate statistics, very vital. Covariance matrix for population, for the sample. Now, come to the sample part. So, sample case we will say sample correlation covariance matrix is S. We will be denoting sample covariance matrix as S. This will also be P cross P matrix. So, my matrix elements I can write like this S11, S12 like S1P, again S12, S22, S2P like this S1P, S2P dot SPP. So, these diagonal elements, these are the variance part and off diagonal element will be the covariance part. Variance and covariance part. How do calculate S11, S12 like this, all the elements of this matrix. So, the general one is here it will be Sjj and somewhere here may be your Skj will be there or Sjk. Correct. So, you can go by the same manner the way you have developed in the univariate case the variance computation. So, Sjj what you will do? We have seen that 1 by n minus 1 sum total of I equal to 1 to n. You have written that x, you have written I, then you have written minus mu that sense, but we will use here it is basically x bar you have used. Now, j is coming into consideration, we will write like this. You can use mu, but here it is mu is not available and we will not when you go for in the sample case we will always write subtract by the sample average. That is why n minus 1 is subtracted. If you use mu here it will be 1 by n. So, this square, yes or no? Then if I can write this one like this 1 by n minus 1 sum total of I equal to 1 to n x I j minus x j bar, again I can write like this x I j minus x j bar, same thing. So, using this I want to write x j k. X j k is 1 by n minus 1 sum total of I equal to 1 to n. First I will keep the j variable as it is, then second case you introduce k. Correct. What is happening here? Actually, if you see in the covariance case or the variance case, the original data matrix is transformed, that we will capture that concept we will take here. You see that x I j minus x j bar, that means for the jth variable every element is subtracted by its average. For the kth variable also, every element is subtracted by its average. Now, if this is the case, can I not write down the two the data matrix in this format like this, that my original data matrix is X, which is x 11, x 21, x n1, x 12, x 22, x n2, then x 1j, x 2j, x ij, then x nj, x 1p, 2p, then x np. So, you have computed here, this is x 1 bar, x 2 bar, x j bar, x p bar. Then you are writing something, you are converting this, that some conversion is taking place here, that is subtraction of mean. Then what are you getting here? If I subtract by mean, I will be getting every observation is subtracted by its corresponding mean value. Okay. So, if I just after this, basically it is a subtraction by corresponding mean, which is this. So, instead of writing this minus this, if I write like this, suppose I will write x star is like this, x star 1 1, x star 2 1, so like this x star n 1. Same manner I am writing x star 1 p, x star 2 p, like this x star n p, somewhere there will be x star I j, general one, where x star I j is x I j minus x j bar. That means this matrix same. Okay. Now, if I use this formula, what will happen then? In this case, that means x I j minus x j bar is x j star, and this one will be x I k star. So, the resultant matrix will be then 1 by n minus 1 sum total I equal to 1 to n x star I j x star I k. Okay. So, this type of conversion will take place, and ultimately little more mathematics that we will see that. I think up to that you calculate this using this formulation. Using this formulation, can you calculate? You take the first data, that this data point you take, the same data point, that first three variable values I think I have given you. Suppose this is my data points. You already calculated mean value. You have to now calculate the variance and covariance part, because there are two variable, only one covariance will be there. Yeah. Then next class will go for the matrix how using matrix multiplication formula we will be able to calculate the covariance matrix totally, then the correlation matrix, all those things. Okay. Thank you.